Hi, my name is Steve West with Premier HVAC Mechanical here in Peachtree Corners, Georgia. We service the Northeast Metro Atlanta area. And today I would like to talk to you about single stage systems versus variable speed systems and zoning. Specifically, I just want to talk about how single stage systems don't really pair up well with when you're trying to zone it, the way the airflow operates. So I just want to touch base on that and explain the difference of why it can damage the system over the long run. So I've got a drawing here. Just typically, this is just a furnace, and then your coil, and then your supply plug right here. And then just to make it all simple, I've got a 12-inch round coming out from the top right here that's going to the downstairs, for example. And then I've got a 12-inch round. I just made them the same size to make it easier for demonstration purposes. So I got a 12-inch round for the upstairs. Each has its own thermostat. So thermostat, then you'll have a zone control board that tells which damper to open and close. So you have to design a system, especially if it's a single stage, if one zone damper is always closed. Because when the single stage system comes on, it comes on at 100%. Okay? So if only one thermostat is calling for heating or cooling, then the other zone is turned off, which means it only needs 50% of the air, okay? So let's just say that this zone, your upstairs zone, is closed. Okay, thermostat is not calling. Well, you're still getting 100% of the air going into this plenum, okay? So you're trying to now get 100% of that air into a 12-inch pipe that is only designed to carry 700 CFM. So we're going to say that this is a 3.5-ton system, which would be half. So half and half. So that would be 1,400 CFM. So if you're trying to get 1,400 CFM into an opening that is only 12 inches round, that can only handle 700. So you're going to have a lot of wind noise, and it puts a lot of static pressure on the system and the blower motor. So when you do that, if you do not have a bypass, so just for this purpose, I just did a 12-inch bypass, that air has to go somewhere to make the air more evenly flow. So what you do, there's several ways you can do this. You'd have to put a bypass in so that the air has a place to go. And then you have what we call a static pressure damper, okay, which is what this is right here. So this, you can set your static pressure anywhere from 0.2 to 0.8. I always set mine at 0.5, which is what the national standard is. Friction rate, static pressure rate. So when it builds up to a 1/2 inch water column, which is how we design systems, then it will open this damper, okay? And when you open this damper, because of the bypass, that extra airflow is going to come down here, but you're recycling it through your return air. So what that can do is that can cause several issues, especially, well, in both seasons, heating and cooling. So let's just say this is a gas furnace, and you're bypassing that already hot air that's coming out of the furnace straight back into the return, and it has a tendency to overheat the furnace, okay? You have high limit switches inside these furnaces. So they'll typically run 6 to 8 minutes, sometimes, depends on what the weather is and the temperature in your house. But they can have a tendency to overheat the high limit switch and cut the furnace off until it cools off enough, and then it'll turn back on again, and then you start all over again. So it's a very inefficient way of doing it. Same thing with the cooling. In the summertime, you have the cold air that's already cooled, and you're just bypassing it, into the return, which can make your coil too cold, especially in the spring and the fall, which can make it freeze up after it's been running for so long. So let's say you have a upstairs thermostat that's calling, because your upstairs in the summertime is what's typically running the most. So you have your upstairs running, but your downstairs thermostat's off, and it's bypassing, right? Well, that upstairs unit's going to run longer than your downstairs. So if it's running for an extended amount of time, that cold air just keeps getting colder and colder, just bypassing through, can cause that coil to freeze up. So that's kind of what the basic design of a single stage system is. Now, there are other ways. I actually like to use the dampers, the supply dampers that have a bypass on them. It's not really a bypass, but a bleed through is what we call them. So we like to use the Honeywells. And it has a setting on here, 1, 2, or 3, so you can actually bleed through. So in other words, if this damper is not calling for cooling, you can set this damper to have a 10, 20, or 30% bleed through. Well, my opinion is I like to use these and set them on 1 for 10%. I would rather at least get some benefit of me paying for the already heated or cooled air being bled into one of the zones that I'm not using. So I'd rather set the bleed through rate on 1, which is 10%. So 10% of that air is still going to go through, even if this zone is off, you can still bleed through 10%, which you will decrease the size of the bypass damper that you need by 10% as well. So you need to put that into your design calculations. So that's how a single stage system works. Like I said, it's not really great for single stage systems when you're zoning because of all this. Now, there is another way that you can do this. You can have what you call a blow-off vent. A blow-off vent would be you're not running the bypass through your return, okay? Let's say this furnace, the indoor section's in the attic. You can go into the hallway and you can just drop a vent in the upstairs hallway. 10-inch vent, okay? So that way, anytime it's in bypass mode, it will bypass that air. Like, let's say you got a tall 2-story family room. You could blow it off into there. So just let all that excess air blow off into what we call a blow-off vent. You could even split them up into 2 different vents or into 3 different vents for different areas. But you try to put it to where the homeowner will not really be paying attention to whether it's hot or cold, because now you're going to be heating an area that's not calling for anything. You're just blowing off the air to try to keep the air from going into the return, okay? So a third way of doing that is, instead of just going straight from the supply plenum down to the return, you can loop this bypass, loop it all the way around and you know, go way over here up in the attic, you got plenty of room, and then tie it back in over here to give it time to cool or heat up. It gives it just loop it all the way around to create more footage, so it has time to warm up or cool down, whichever way, heating or cooling season, before it hits that return at such a close distance. That'll help a little bit. So each situation is different. I typically like to do, personally, the bypass down here, use the bleed through up here. If I need to use the bleed through 20%, the only problem with that is some customers don't like the fact of losing the temperature control even that much. They'll sometimes complain about, well, my upstairs thermostat's off, but it never comes on because it's always staying at that temperature because of the bleed through airflow that's coming through. In other words, it's cooling the area a little bit without it calling for it because you're getting that bleed through. So that gets me into my 2-stage and communicating systems to talk about next. So we are a Carrier dealer, so I'm going to talk mostly about the Carrier Infinity. We also offer the 2-stage, but I'm going to skip straight over to the Infinity because that's what I think is best for zoning, just the way it controls the airflow more, which I'm about to explain. So the Carrier Infinity zoning system. So you have, here again, thermostat for upstairs, have a thermostat for downstairs, and you got a zone board. So it'll be a Carrier zone board. So the Infinity system, communicating system, you can set each zone for how much CFM you want it to call for. It also communicates with the outdoor unit. Outdoor unit is a 5-stage. This is our VNA 9 product, or any of our VNA Infinity systems. It's a 5-stage outdoor inverter system. So it goes from 20 to 25% all the way up to 100%, and it ramps up and down for the cooling. The furnaces you can get with a variable speed, which ramps up and down as well. That's what helps control the humidity in your spring and fall. And you can also go to a modulating furnace on the heat side, which is the top of the line that you're modulating at 1% increments in the wintertime. So that's what helps keep it a steady stream of air in your house. So going back to the dampers, so Carrier Infinity dampers are a 15 position damper. So it opens and closes as the system is calling for it. So the system is constantly communicating with each zone. You got a zone sensor and then your main thermostat. So it's constantly going, okay, how much airflow do I need in this zone to meet the temperature requirements at a certain humidity level requirements that you set in the parameters. And in the controls on your main controller, you can, like I said, set how much CFM you're designing for each zone. So let's say you've got a 12-inch zone and a 12-inch zone, and then let's say this is a 5-ton unit, and you have another, let's say a 10-inch zone. I just want to make one different. You can design each zone in the settings, in the pro settings, how much airflow is going to be going into each zone. And that's where that 15 position damper comes into play, because it helps modulate the airflow. It's design. It's controlling how much airflow each zone gets. So when you do that, because the airflow isn't coming on at 100%, then you don't need all this bypass nonsense. You get rid of all that. Okay, so you're getting rid of the stress that you are putting on your single stage system, because now you are controlling. You're not coming on at 100%. You may only come on at 25% on very low stage. You may come on at 70%, then it drops down to 20% and run there most of the day. Depends on what the temperature is. So there's a lot of benefits to a variable speed system. They're more expensive up front, but the long-term of energy efficiency savings and comfort. You always hear people, are you looking more for comfort, or are you looking for price? Are you looking for budget? Are you looking for the best or the middle of the road? So, comfort comes into play, then it becomes budget. So comfort and budget are two different things. So that's what I like about the Infinity systems. Now the 2-stage, when we drop back down to the middle of the road, 2-stage kind of works the same way, but you're not dealing with the 15 position zone damper. It's basically open and closed. Okay, 2-stage will work if you are pretty even in what size are your zones. Like if you have a 12-inch and a 12-inch, because your first stage is going to come on at 60 to 70%, depending upon which brand you have, and then it's going to go to 100%. It's not as communicating, it's more about time. In other words, if it doesn't cool the area down within so much time, it'll ramp up because it's calling for more demand. It does good at controlling humidity, not as well as the Infinity system, because Infinity's constantly modulating and taking temperature readings, which is a true communicating system. This is it's a semi-communicating system. It's not as good, but it's much better than single stage. So 2-stage will work if you've got pretty close to size and same size dampers, like for upstairs and downstairs. Now I want to go over static pressures on how you design these bypass dampers and ductwork. So on the supply side, this is where I see, when I go on changeouts, estimates for changeouts, this is where I see a lot of mistakes of previous units that have been installed in the past. There's hardly ever enough return air, okay? Especially homes that are 8, 10, 12 years or older. And this is 2024, so things are way different now than they were back then. So you design your supply duct at 0.10 static pressure, okay? And you design your return duct at 0.05 static pressure. If you'll notice, that is half. That's almost half, okay? So a supply 12-inch duct can put out 700 CFM, okay? A 10-inch round duct can put out 420 CFM. On the return side, a 12-inch duct is only going to pull back 475. Big difference, right? 10-inch will only pull back 300. So roughly about a third less. So what I normally see, most homes, I'm going to say probably 70% of the homes I go on, we have to add return air, okay? Which is very important, especially when you get into Infinity systems, because Infinity systems are so technical, and they are constantly running tests and checking the status of the system. It does a one time a day, normally set up for 3 or 4 o'clock in the morning. It does a diagnostics on the system that's checking static pressure. If you do not put enough return air on these Infinity systems, it will kick out error codes, okay? And your customer's gonna know it. These Infinity systems, if you don't know what you're doing, they will tell on you, and they will tell on you to your customer. They will know. So you have to take return into account. The other thing about poor return is it makes the static pressure be higher, which can damage the system, even if it's just a 2-stage. See, 2-stage isn't doing a diagnostics check. Single stage or 2-stage won't tell on you if you're short on return air, but the Infinity will. The biggest thing, if you don't have enough return air, it can make your high limit switch on your furnace go bad. But anyway, so I'm kind of getting off topic, but going back to static pressure, you always have to look at your static pressure, look at your return ducts, supply ducts, to make sure that you have enough return air coming into the system. A system cannot blow out what it can't suck in. So that's all I'm going to talk about for this topic for now. I hope you look out for our future videos, and thanks for watching.